We interact with digital information every day, treating it like a weightless, invisible resource. But data has a physical presence. Everything starts with 1 byte, 8 bits, just enough memory to store a single letter, like an A. Visually, we can represent this base unit as a tiny cube, measuring exactly 1 centimeter across. Multiply that by 1,000, and we reach the kilobyte. In modern terms, that is the size of a short text message, or a few lines of code. In the early 1980s, entire interactive worlds existed within these limits. Classic arcade games like Space Invaders ran entirely on just 8 kilobytes of ROM. At this stage of computing, information was a scarce resource. It was measured in amounts small enough for a human being to visualize and track easily. Scaling up by a factor of 1,000 brings us to 1 megabyte. If our byte is a tiny cube, a megabyte forms a 1-meter block. This volume used to require dedicated physical space, like the classic 3.5-inch floppy disks used to boot games or save school assignments. Pushing past a few megabytes meant dealing with extreme financial and physical constraints. In the late 1970s, an IBM Winchester drive offered 35 megabytes of storage. It came in a 25-pound module and cost around $10,000, the price of a brand new car at the time. This visualization shows how massive these volumes become when we skip past the gigabyte and jump to the terabyte. Our 1-centimeter cube has grown into a 110-meter block of pure data, standing nearly 40 stories high and taller than Big Ben. Right now, that massive structure fits inside your pocket. A modern 512 gigabyte or 1 terabyte smartphone holds more storage capacities than every single computer on Earth combined in the entire 1980s. Personal storage has reached a state of everyday abundance. We carry massive, invisible libraries in our pockets as a standard feature of modern life. The terabyte is where the personal scale ends. Beyond this, laptops give up and global infrastructure takes over, moving into massive, automated data centers. We reach the petabyte. Visually, this is a glowing megacube stretching a full kilometer on every side. If you printed a petabyte of plain text, the stack of paper would reach 50,000 kilometers into space, 1/8 of the way to the moon. Next is the exabyte, an 11-kilometer cube large enough to swallow entire city neighborhoods. This is the threshold of true internet scale. Today, humanity generates over 13 exabytes every single day. That equals the data required to stream every movie ever made 150 times over, every 24 hours. At this volume, data generation is a massive, continuous byproduct of human existence. It operates at a scale that only machines can manage. Looking at this metropolis diagram, we see our next jump, the zettabyte, a 100-kilometer block dwarfing the city below. Growth is exponential. In 2020, we reached 64 zettabytes. By 2025, that total is projected to hit 181 zettabytes, tripling in 5 years. This curve presents a physical problem. We are generating digital information faster than we can manufacture the hard drives required to hold it. Our digital footprint has officially escaped our physical ability to manufacture enough hardware to contain it. This brings us to the final jump in scale, the yottabyte, represented as a 1,000-kilometer cube. Storing this amount of data is currently impossible. Even if we used every single storage drive humanity produces in a year, it would take more than 1,000 years of continuous manufacturing to hold just 1 yottabyte. This cube marks the absolute upper limit of our current measurement systems. It is the edge of what we even have a word to describe. Yet, all of this staggering vastness relies on a single foundation. Everything starts with 8 bits, 1 tiny cube. In just a few decades, the volume of data we produce has scaled into a territory that exceeds the boundaries of human comprehension.